Alright guys, so we're going to take a look at section 3.7. This is the last section before the review, before we look at the next test, alright? So let's see what's going on here. We're given this set of data, which is the price of college textbooks as compared to the number of pages are in the book. So they give us a scatter plot with across the bottom we have how many pages are in the book, and then across the top is how much it cost. And so this is what we got going on. And it looks like there's a pretty nice linear thing going on. They tell us here in a second that the correlation coefficient is actually 0.62, I believe. I want to say it's 6.2 or 6.8, one of those two numbers. But so that's our correlation coefficient. So it's got a pretty good linear thing going on. One of the ways to choose where to draw the line is, rather than just kind of like picking it wherever, is you can pick two of the points that kind of best summarize the line. So if you're looking through here and you're thinking, okay, where does the line, where would the line fit the best, I don't know exactly where it is, but what looks like pretty good is maybe this point right here and this point right here. If we drew a line connecting those 2 points, it would probably fit, pretty good. So let's go ahead and do that. Let's draw the line right here. So right here and right here. There's our line. Okay, so we draw the line connecting those 2 points, and we're going to kind of just stick with it. Say that's our line. Okay, that's whatever this line is. We're going to just kind of dive in and say that's our line that fits the best, the line of best fit. The equation of this line actually ends up being this right here. Let's write it down. We get y hat equals 0.22 times the pages minus 3.92. That's the actual equation of the line. Alright, so now they wrote it in kind of a backwards how we've been writing it. Normally write it as, y hat is a plus bx. They put the slope and the pages first, so this is like bx minus a, kind of, if you want to say it that way. So they kind of switch the order on us. They did the multiplication first, and then they're putting in the intercept right here. But so that's what we got going on. So 0.22 times pages minus 3.92. That's our equation for this line that goes through these 2 points. And so what we want to do real quick is go ahead, let's predict what would happen, how much, if we know the number of pages, we want to predict the amount of money it would cost for a book that has, let's do 696 pages. So we're going to predict a 696 page book. So the pages, that's the x value. So if this is our equation right here, we can write this as y hat equals 0.22x minus 3.92. That's kind of a nicer way to write it that way. So let's go ahead and we're just going to plug in 696 in for x. So y hat equals 0.22 times 696 minus 3.92. And then let's see what happens here. So we grab the calculator. So if we do, let's see, we do 0.22 times 696, that equals 153.12. And then we subtract the 392 minus 3.92, and I get 149.2. And that's what I got there. So if all I knew was that I had a 696 page book and I was using this line to predict what was going on, I would say that my 696 page book would cost $149.20. That's what I have figured out. Now here's the thing. That would be, let's go ahead and put that point on the line here. 696 would be right here, pretty close to 700, and it would be up here on the line. Whenever we predict something, it's always right on the line. So we're going to come up here and right on the line, bam, it would be right there, right at that X. Now here's the thing, I specifically chose 696 because we actually have a book that was 696 pages right here, and it costs $122, not $140 something. If we look at the graph, 696 and 122. So that's 696. There it is right there. This point right here, that's the book that costs $122. That was 696 pages. So if you look, we used our line to predict what it would be, but the actual book was actually was cheaper. We have overshot. We guessed too high. Our prediction was too high for this point. All right, because our actual data had a value that was less. Our prediction gave us, when we used this line, we kind of relied on this line, and we guessed something that was too high. And that's not bad. I mean, for some of these, we'd guess too low or something like that. But I mean, and we can't be perfect. You know, this is going to fit the best it can. But just for this particular one, we guessed too high. And so what happens is we now have a kind of a gap between our prediction and the real book down here. This space right here, this distance, is called the residual. The residual is how far away it is from the actual point to the predicted point. So from the actual point we had to the line, how far it is to the line. There's a formula for it, and it goes like this. The residual is equal to, in our situation here, it would be the actual price minus the predicted price. Actual price minus the predicted price. I'm running out of paper here, so I had to scrunch it together. So in this case, the residual for the 696 page book, the actual price was 122. So we would do 122 minus the predicted price we got, which was the 149.20. 149.20 equals, so what did we get? 122 minus what we got before, and I get negative 27.2. That is the residual for 696. That means that if we use the line to predict a 696 page book, we overshot by 27.2. The real data is 27.2 below what we actually got. That's what a residual is all about. Okay, and the idea behind the line of best fit is to kind of have all the residuals be as small as possible. So all the dots should be as close as possible to the line if you go in that vertical distance. All right. But so I just kind of wanted to clear up any confusion about what a how to make the prediction, and then how to compare our predicted amount to our actual amount and come up with our residual. Okay? All right, so this ought to help you out for these first few bits, and then let me, here in a second, we're going to kind of formalize a little bit more residual stuff, and then we'll keep on going. All right? Hang on a second.